Hi friends, in this video we are going to discuss about constructional details of a DC generator. So this is the DC machine. The DC machine consists of two important parts. One is stator, another one is rotor. Stator is nothing but the stationary part. Rotor is a rotating part. Okay, so these are the stationary parts in the DC machine. The first one is pole core and pole shoe. Second one is field coil, yoker, magnetic frame and brushes. These four are the stationary parts in a DC machine. And coming to rotating parts, armature core, armature conductor, commutator, shaft, bearings. These are all rotating parts in a DC machine. Let me see one after one. The first one is yoker magnetic frame. This is the outer frame of a DC machine. It protects all parts inside the machine and it supports the magnetic poles, and also it provides low reluctance path to the magnetic flux. Okay, and the second part is pole core and pole shoe. So this is the pole core. So in this diagram you see this is the pole core and this is the pole shoe. The pole core and pole shoe combinedly known as pole, a magnetic pole. Okay, so what is the purpose of pole core and pole shoe? Actually, the pole core is used to hold the coil or to support the field coil, and the purpose of pole shoe is to spread out the magnetic flux into the air gap. It spread out the magnetic flux into the air gap. Okay, and the third one is field coil. So this is the field coil or pole coil. So the field coil is connected to DC supply and this is wound on the pole core. When we connect to the DC supply, the DC current flows through the coil and flux produces inside the pole, and this pole spread out the flux into the air gap. Okay, and next, brushes. I will tell you brush finally. Okay, and coming to rotating part. So the next part is armature core. So this is the armature core and these red dots are the conductors in the slots. Okay, the gap between pole shoe and armature core is called air gap. So this is the air gap which is between pole shoe and armature core. The flux always filled in the air gap. Okay, and coming to armature core. Armature core is a laminated structure. It is made with silicon steel laminations and the slots are provided in the outer periphery of the armature core, and here we have number of slots in the outer periphery of the armature core. The conductors are placed in the slots like this. Okay, so next, this is the commutator. These are the lines or the commutator segments. The purpose of commutator is to collect the current from the armature conductors, which is AC, converts into DC. The purpose of commutator is to collect the current from the armature conductors which is in form of AC. It converts into DC. Okay? And coming to brushes. So brush is a stationary part. Even though it is placed in the rotating part, it is a stationary part. It is not moving. It rests on the commutator segments. Okay? So that's why the purpose of brush is to collect the current from the commutator and gives to the external circuit. Brushes are made with copper or carbon. Commutator segments are made with hard drawn copper. Armature winding is made with copper or aluminium. And the armature core is made with silicon steel thin laminations. Pole core and pole shoe is made with sheet steel or silicon steel laminations. Yoke is made with cast iron for small machines, fabricated steel for large machines. Okay? So, and let me see how the DC machine works. According to Faraday's first law, whenever a conductor cuts the magnetic flux, an EMF induced in the conductor. So, here, when we give DC supply to the pole spread out the flux into the air gap. Now, flux is ready. Here, we are arranging armature winding or armature conductors in the outer periphery of the slots, outer periphery of the armature. So when we give motion or when we connect the shaft to the prime mover, when prime mover rotates, the armature rotates. When armature rotates, the conductor cuts the magnetic flux and EMF induced in the conductor. So in this way, the EMF induced in a DC generator, but the induced EMF is always alternating current, not DC. This AC converts into DC with the help of commutator, and the brush collects this DC supply and gives to external circuit where we connect the load. So this is the matter about constructional details of a DC machine. In next video, we will discuss about EMF equation of a DC generator. Okay, bye.